Good morning, parents, teachers, and learners. We are now on the ninth lesson of the second quarter, which is entitled Problems Involving Radicals. After mastering the required skills about radicals, we will now apply those by solving real-life problems involving radicals. So are you ready? Let's do this and let us solve those problems with Sir Jude. Let me present to you our objective for today. At the end of the discussion, you should be able to solve problems involving radicals systematically. Have you ever tried solving for the length of the side of a square or a rectangular garden and its diagonal? Let us say that you are to fence the garden and you are given with the area. Or have you ever tried solving for the side of the right triangle that you made after biking a certain distance? Let us say the distance from your starting point to the ending point. How about exploring and solving for the velocity of an object given its mass and kinetic energy? Wow, that's physics. How about coming across with a thought of estimating the speed of a tsunami? That's unbelievable. These are only some of the few applications of radicals in real-life situations. Let us have some of these examples of solving problems involving radicals. For us to be guided in solving problems involving radicals systematically, after reading and analyzing the problem, we will be following these steps. Step number 1. Identify the given information and illustrate the problem if it is possible. Step number 2. Substitute the given information to the formula that we are to use. Step number 3. Solve for the unknown and check for possible extraneous solution. And the last step, step number 4, state the final answer. Do not forget to include the units and express your final answer in complete sentence. We are now ready to solve. Let us have problem number 1. Valenzuela City will launch an urban gardening contest as part of the Clean and Green campaign. This will feature floral displays, gulayan sa bakuran, and the use of recyclable materials. You and your brother decided to join the contest by dividing the rectangular lot available in your backyard. It is 5 meters wide and 12 meters long. If you will divide it by fencing diagonally to produce 2 garden entries, how much fencing wire is needed? After solving and analyzing the problem, we proceed with step number 1. Out of the statement in the problem, we need to identify the given information that will help us solve it. So we are given with the width and the length of the rectangular lot, which are 5 meters and 12 meters respectively. So let us show it using an illustration. So let us suppose that this is the rectangular lot. So the width is 5 meters and the length is 12 meters. We are asked to solve for the length of the fencing wire needed to divide the rectangular lot diagonally. Take a look at the figure. What kind of triangles are formed? Very good. These are right triangles. In solving for the missing length of the side of a triangle, we will be using this well-known formula or theorem. This is the Pythagorean theorem. This theorem is well known, especially when we are solving the length of the side of a right triangle. This was associated to a Greek mathematician and philosopher known as Pythagoras. The Pythagorean theorem states that The sum of the squares of the legs of a right triangle is equal to the square of its longest side, called the hypotenuse. In mathematical equation, we have the first leg squared plus the second leg squared is equal to the hypotenuse squared. If we will let A be the first leg, then it will be A squared plus, if B is the second leg, the result will be B squared is equal to, if we let C be equal to the hypotenuse, then it will be C squared. A squared plus B squared is equal to C squared is the common notation or representation used for the Pythagorean theorem. A right triangle has two legs. These are the sides of the triangle that are perpendicular, or the ones that forms a 90-degree angle. On the other hand, the hypotenuse is the longest side, or the side opposite the right angle. Since the illustration that we formed in problem number 1 is composed of right triangles, and we are to solve for the missing side, let us use the Pythagorean theorem. As stated in step number 2, we need to substitute the given information to the formula. In this problem, the formula that we are going to use is the first leg squared plus the second leg squared is equal to the hypotenuse squared, given by the Pythagorean theorem. Then let us identify the legs and the hypotenuse. Let 5 meters be the first leg. 12 meters be the second leg. Therefore, the problem asks for the length of the hypotenuse, and let us say that it is represented by x. Substituting the values, we now have 5 squared for the first leg plus 12 squared for the second leg is equal to x squared. Let us continue solving the given equation and go to step number 3. Step number 3, we need to solve for the unknown. So from this equation, 5 squared is simply 25 plus 12 squared is 144 is equal to x squared. We add 25 and 144. That's why we can obtain 169 is equal to x squared. Let us use the symmetric property and extract the square roots of both sides of the equation. If you can see, this will require your skills in simplifying radicals. The square root of x squared is equal to x, and the positive negative square root of 169 is positive negative 13. Take note that we have two values of x. These are x is equal to 13, and the other one, x is equal to negative 13. Since we are solving for the measurement, we only include positive 13. On the other hand, how do we call a solution or root that does not satisfy the given equation? Absolutely, it is called an extraneous solution. So for the final answer, as suggested in step number 4, the length of the fencing needed to divide the rectangular lot diagonally is 13 meters. I hope that you will join this urban gardening contest if you are given a chance to join. During this pandemic, plantitos and plantitas trend, most especially in social media. Are you one of them? A question to ponder. What do you think are the benefits of putting a garden in your backyards? Aside from beautification of surroundings, it helps our ecosystem and it regulates the food web in our places, as plants provide food and resources to other living organisms. It can also be a source of food without spending in the market. In addition, It can replenish the air that we are breathing by providing oxygen. And lastly, plants in our gardens can boost our positivity and mood by reducing the release of carbon dioxide. Speaking of gardens, share ko lang. Did you know that the world's largest natural flower garden can be found in Dubai? It is what do we call as the Dubai Miracle Garden. It is the world's largest flower garden that has an area of 780,000 square feet. Would you believe that? This garden won 3 awards that put them in the Guinness World Record. To be specific, in 2016, 2018, and 2019, which features different floral designs. Let us now go to the next problem. Problem number 2. Today is another FB live streaming. As I went to Valmasay, I traveled 2 kilometers east and another 4 kilometers northward. How far am I from the starting point, which is my house? For us to be guided by the directions, let us use this compass. There. The given is I traveled 2 kilometers east and another 4 kilometers northward. Let us use this illustration. If you can see, we are to get the distance from the house to Valmasay. It is also visible that the figure formed is a right triangle. It suggests that we need to use the Pythagorean theorem. For step number 2, let us identify the legs and the hypotenuse, then substitute them to the formula. The first leg is 2 kilometers, and the second leg is 4 kilometers. We need to solve for the length of the hypotenuse. Let us use D to represent it. Thus, if we are going to substitute to the given formula, that will be 2 squared for the first leg plus 4 squared for the second leg is equal to D squared. Let us continue the solution and proceed to step number 3. So we all know that 2 squared is 4 plus 4 squared is 16 is equal to D squared. Adding 4 and 16, the resulting equation is now 20 is equal to D squared. Then, we extract the square roots of both sides of the equation. Since 20 is not a perfect square, let us think of factors of 20 with one of its factor a perfect square. In this problem, again, we need your skill in simplifying radicals. Let us continue. The square root of D squared is D. So that the factors of 20 are correct. We have 4 and 5. The positive negative square root of 4 is 2. Then, the simplest form of the expression is positive negative 2 square root of 5 is equal to D. If you can see, we obtained 2 values of D. Just like in problem number 1, we need to take the positive value since we are dealing with measurement, this time distance. So we have the first value, D is equal to 2 square root of 5. The second one is D equals negative 2 square root of 5. The answer here is 2 square root of 5. And the second one is considered as an extraneous root. So therefore, for the final answer, the distance from my house to Valmasay is 2 square root of 5 kilometers, which is approximately 4 and 47 hundredths kilometers. To further understand our lesson in solving problems involving radicals, let us have another example. Problem number 3. A fire was reported due to a faulty wiring. A ladder was used by brave Valenzuela firefighters to rescue a man on the second floor of the burning house. Suppose that the foot of the ladder was 4 square root of 3 feet away from the wall, and the top of the ladder reached the height of 11 feet. How long is the ladder used? We will go with step number 1. The given information that we can use is the ladder was 4 square root of 3 feet away from the wall, and the top of the ladder reached the height of 11 feet. Illustrating this situation, we have this figure, a burning house. So we are going to determine the length of the ladder. The foot of the ladder from the wall is 4 square root of 3 feet, while the top of the ladder reached 11 feet. What is the figure formed? Correct. It is a right triangle. Step number 2. Using the Pythagorean theorem, we can solve for the length of the ladder. Let us identify the legs and the hypotenuse. So we let 4 square root of 3 feet be the first leg, and 11 feet be the second leg. The length of the ladder is the hypotenuse, and let us represent it as L. Substituting the values to the formula, we have 4 square root of 3 squared for the first leg, plus 11 squared for the second leg, is equal to L squared. Let us continue solving and proceed to step number 3. By squaring 4 square root of 3, it will now be equal to 16 times 3. 11 squared is 121, equals L squared. 16 times 3 is 48, plus 121 is equal to L squared. 48 plus 121 is 169, equals L squared. To solve for L, we need to extract the square roots of both sides of the equation. So we have L is equal to positive negative 13. Only the positive value will be accepted, and that is L equals 13. And then the other one is considered as an extraneous one. So for the final answer in this problem, the length of the ladder that is used to rescue a man has a length of 13 feet. Let us have some trivia about fire incidents since we dealt with that with the problem. Share ko lang ulit. Important that you know what to do in case of fire. Be sure that someone knowledgeable regularly check your house electrical wirings. Do not leave your stoves and other cooking equipment unattended. These are only some of the few things that we should practice at home to avoid fire incidents. Going back to our topic, these are some of the examples of problems involving right triangles that apply the principle of radicals. Let us have this one. Would you believe radicals are used to solve cases like car accidents? Investigators and the police department uses the formula given by V is equal to 2 square root of 5s, where V is the speed of the car in miles per hour and S is the distance traveled after the brake is applied, which is measured in feet. This can be measured using the skid mark. Problem number 4 has something to do with this formula. Suppose that you are part of the Valenzuela scene of the crime operatives and you are asked to investigate a car accident or incident. Your team leader asks you to compute and estimate the speed of the car using the formula V is equal to 2 square root of 5s. Again, V is the speed of the car in miles per hour and S is the distance traveled after the brake is applied. If the skid mark made has a length of 125 feet, what is the speed of the car? To solve this problem, let us identify the given and illustrate. It was stated that the length of the skid mark made by the car has a length 125 feet. By the way, a skid mark is a long black mark left on the road surface by the tires of the skidding vehicle. So this is our skid mark. The measure is 125 feet and we are asked to find the speed of the car. Let us go to step number 2. We are given with the formula that we are going to use and that is V is equal to 2 square root of 5s. Let us substitute 125 feet, which is considered the length of the skid mark, in replace with variable s. There. Let us simplify the resulting equation and proceed to step number 3. So from V is equal to 2 square root of 5 times 125, multiplying the radicand 5 times 125 will give us the equation V is equal to 2 square root of 625. 625 is a perfect square and it has the square root equal to 25. 2 times 25 is 50. Thus, V is equal to 50 mph or miles per hour. So out of the solution that we made, we solve for the speed of the car, and the car is traveling 50 miles per hour before applying the brake. This is approximately 80 and 4700 kilometers per hour. Is a scene from the movie San Andreas, which was released in 2015. This movie shown series of earthquakes that eventually resulted to a tsunami. What is a tsunami? A tsunami is a series of ocean waves that sends surges of water, sometimes reaching the heights of over 100 feet onto land. These walls of water can cause widespread destruction when they crash the shore. It is usually caused by undersea earthquakes at tectonic plate boundaries and volcanic eruptions. Would you believe that radicals are also used in estimating the speed of a tsunami? This is given by the formula S of D is equal to the square root of 9.8 times D, where S of D is equal to the speed of the tsunami in meter per second. and D is the depth of water in meters. Let us apply this formula as we solve a problem about tsunami. Problem number 5. An underwater disturbance occurred somewhere at the South China Sea that has a depth of 4,500 meters. HAAWK raised a tsunami alert. Question number 1. What is the speed of the tsunami? Using the formula S of D is equal to square root of 9.8 times D. Second question. If the location of the disturbance where the tsunami started was 2,700,000 meters away from Valenzuela City, how long would it take the tsunami to reach Valenzuela? And lastly, how is knowing the speed and the location of the disturbance that uses radicals relevant to us? Let us solve this one by one, starting from question number 1. So out of the given problem, we know that the underwater disturbance has a depth of 4,500 meters. Step number 2. We are given with the formula, which is S of D is equal to the square root of 9.8 times D. The given 4,500 meters will be replaced in the variable D to the formula. So that will be S of D is equal to the square root of 9.8 times 4,500. Let us continue solving. Step number 3. From S of D is equal to the square root of 9.8 times 4,500, we will multiply 9.8 and 4,500, obtaining S of D is equal to the square root of 44,100. 44,100 is a perfect square. The square root of 44,100 is 210. Thus, S of D is equal to 210 meters per second. So the estimated speed of the tsunami is 210 meters per second. After knowing and solving the speed of the tsunami, let us answer the second question. If the location of the disturbance where the tsunami started was 2,700,000 meters away from Valenzuela City, how long would it take for the tsunami to reach Valenzuela? Remember that the speed of the tsunami is 210 meters per second. To get the estimated time before the tsunami hit Valenzuela, we need to divide the distance of the disturbance to Valenzuela and the speed of the tsunami. So that will be 2,700,000 meters divided by 210 meters per second. Simplifying, we cancel meters and we are left with seconds. 2,700,000 divided by 210 is approximately 12,857 and 14 seconds, or approximately 3 and 57 hours. So if we are residing in Valenzuela or to places near Valenzuela, we only have less than 4 hours to prepare. The next question is, how is knowing the speed and the location of the disturbance, which applies radicals, relevant to us? Comment down your insights. This is important for us to know the span of time for the preparation to evacuate to higher grounds. Same for those who resides near our city. This also reminds us that not only earthquakes, fires, and flash floods are possible. We we should always be ready and know what to do during these times of disasters. That's why, if we can remember, during our face-to-face classes, we are being trained by our STRRMC about the disasters that might come. I hope that you can now appreciate the importance of mathematics in real life, especially this abstract and vague topic known as radicals. So to sum up today's lesson about solving problems involving radicals, here are some points to remember. The steps in solving problems involving radicals. Step number 1, identify the given information and illustrate the problem if it is possible. Number 2, substitute the given information to the formula that will be used. Step number 3, solve for the unknown and check for possible extraneous solution. The last step, state the final answer. Do not forget the units and it should be expressed in complete sentence. We also need to check and sort the solution to the values of the unknown that we get because there might be extraneous solutions. This is Mr. Giancarlo M. Pilapil saying, good day and God bless.